Hello everyone, welcome to my YouTube channel. I hope you are absolutely fine. Today we are going to solve 701 insert in a binary search tree. So we have given a binary search tree means the value of the left hand side is less than the value of the root and the value of the right hand side like right subtree is greater than the root. So we have to return the root, sorry, we have to insert a child like we have to insert a node into our binary search tree, a value is given. So we have to make a node with this value and insert to the right place of the binary search tree. After that, we have to return the root. So it is guaranteed that the value does not exist in a original tree. Like all the values are unique in this tree. So it also says if there may be multiple ways for the insertion. As long as the tree remain the binary search tree after the insertion, uh, you can return any of tree. We can insert the node into multiple ways, but it should follow the condition of the binary search tree. All the answers are valid. So let's see how we are going to solve this problem. In this example, we see we have given a binary search tree 4, 2, 7, 1, 3. We have given a binary search tree and we have given a value 5. So we have to create a node with the value 5 and insert to the right position of the value. So starting from the root, so our value 5 is greater than the root, means it is definitely lie on the right hand side. So it will lie on the right hand side, so we cannot go to the left side. So we have to go to the right side, means the value lies on the right side. So what is the value of the right side? Right side value is 7. So our current node value is 5, which is less than the value of 7. So the value will does not lie on the right hand side. It will lie on the left hand side. So left hand side does not have any node, means we reach to the null. Then we will create a node with the value 5 and attach to this node. Then this is our answer. Similarly, like for other other answer can be also accepted, this is also accepted, this is a tree where all the element on the left subtree is less than the node and right subtree is greater than the node. Let's solve this problem by this example. So we are starting from the root. In the edge cases, we have given like a number of node can be 0. The number of node can be 0. So if number of node is 0 means our root equal to null. If it is null, root equal to null, then we create a new node and return it. Like if our root is null, then we create a new node 5 and return it. This is our valid answer. Otherwise, we have to insert the node into our tree. So we go to the left side, like we start from the root. So we go until our root, until we have to keep track of root. So this is our root. We create a node n. We move until our node n equal to not null. Until our node is not null. So if our value if our this value is less than our node value, then we go to the left side. Otherwise, we go to the right side. So if we go to the right side and our node is null, like we go to the right side and it is null, left is null, then means we have to insert the value. Like let me show you the code, then you will better understand. Like this is our code. So the code explains if our root equal to null, then we create a new node and return that node. Otherwise, we create a tree node which is pointing to the root. Then we will move further. We will move further until our node is not equals to null. Means we does not traverse all the nodes. So if our node dot value is less than value, Like this is example for the right case, like our node dot value is less than our given value. So like in this example, you can see our node dot value is less than value. So we go to the right. Like this is for the right, we go to the right. This is for the left. In also there are the cases like we go to the right and it is null. Then we cannot go further. So if we cannot go further, then we create a node and add it to the node dot right. Then we create a node and add it to the node dot right. So if like in this example, uh, node dot value less than value, then we go to the right. Like node dot right equal to null. So node dot right is not equals to null. So we go to the node equal to node dot right. Then we go to this. Now we are at this. So our value 5 is less than 5 is less than node value means we go to the else condition. In this condition, like a 7 is less than 5, so it is false. Then we go to the else condition. So our node dot left equal to null. So you can see like this is null, node dot left equal to null. So if it is null, then we create a new node 5 and add it to node dot left. And after adding the value, we will return our root. We do not need to further proceed. We simply return our we simply return. Then if it is not the case, like if there is any value, then we go to that node and again check this all this condition. So in this way we are going to solve this problem. Like you can see like if we have to now add 6 into it. uh what is 1 2 3 4? Like assume we have to add 4.5. I can understand ki it is not an integer value, but let's assume we have to add 4.5. Sorry, 3.5. Let's assume 3.5. I want to add it on the right side. So 4 is greater than 3.5. So the value 3.5 will lie on the left hand side. Then we go to the 2. We go to the 2. Then we check the condition like 2 is not equal to null. So 2 is not equal to null. Then we go to the 2. Then 2 is less than 3.5, then we go to the right. So if right is not equals to null, then we go to the right. Then again we check 3 is less than 3.5, when we have to again go to the right, but right is if right equal to null, then we will add a new node 3.5 and we will return. Simply we will return. So this is the overall code how we are going to solve this problem. So what is the time complexity of this code? So big O of n for the space complexity. Like we are traversing the node only once, so we go off one. Like sorry, the time complexity is log n. Time complexity is log n. Time complexity is log n because we are choosing like we have to go to the left side or right side. So time complexity is log n. And space complexity, we are not using any extra space. We are not using any extra space. So space complexity will be big O of 1. So this is the code. So if we talk about the summation, so let's see what is the time complexity. So time complexity was log n, and what is the space complexity? So space complexity of big O of 1. So this is the solution of this code. I hope you like this solution. If you like, then please uh, share and like this video. Thank you very much.